So till yesterday we had covered up till this point where we have started the routing part, but today we'll elaborate more on this and here I'll show you how to start with the routing. Here are the tools that will help us while working on the board layout part, and in this case we'll first tell you how to delete any unwanted traces. We will use the rip up tool. We'll click here. So this tool helps in removing any unwanted traces. For example, let's say you want to delete all the traces that are present. You can go to rip up tool and you can simply click on all signals. Once you press yes, all the traces that were previously drawn in either top or bottom layers will be deleted. Now you can start fresh, and some settings that are required for routing will just let you know. So we'll click on route airwire. First of all is the layer setting. So normally on a single sided board, we use the bottom layer for routing, and we can choose the walk around obstacles option here, so that Eagle will guide us by moving the track away from any obstacle in the place. We'll select the second option in the angle part. It will be a 45-degree angle that we'll be making while moving the track. Normal width for the power signal that we had done yesterday was 16 mil for the default trace, whereas for the power traces 24 mil width of the track was suggested. So since we'll be routing the power traces first, we'll use the 0.024 option, and this is recommended because in toner transfer method uh, thickness of trace should be higher so that it is transferred properly, and during the process of fabrication, even if some amount of copper is removed, even then a significant amount will remain. So here we have the drill setting, diameter and other options available. So as you can see, we have mentioned the drill size for via to be 0.9 or 1 mm. So we are going to use that option. And to switch to mm setting, we'll go to grid and we'll select the size as unit as mm. So now the drill is set to 1 mm, as you can see. And now we'll go back to the int setting again and we'll start routing the traces. And also before starting routing, you must check the placement of the components, that it is as per some rules that we have in place, so that the functioning of board is optimum and the one component is not hindering the another component. So let me just show some rules over here. You can take the snapshot of this image also, like what will be the rules for component placement. So with respect to connector, the connector should always be placed on edge. It can be any of the edge or it can be as per your requirement, but should be placed on the edge itself so that access is easy. And with respect to indicators, so by indicator I mean LEDs or any display. They should be placed in area where the visibility is not hindered by any of the nearby component. For example, if any nearby component have very higher height or higher profile than the LED, then it might be the case that LED may not be visible from all the sides. So you should take care of that. And placement of such components like indicators should be in an empty space where nearby components are not of very higher height. Then we have heat generating components such as regulators, resistors, and other kind of heat generating components. The placement of such components should be in a way that the cooling of the component is supported, which means that the component have an easy airflow around all of its sides, and we might even be required to place some heat sink, or we might even be required to place a large copper pad to prevent the heating and to radiate the heating in this case. Then we have the placement of antenna, and the placement of antenna should be in such a way that the signal is received optimally, and in some cases it might be even required to give a cutout in the PCB so that the signal is not influenced by the PCB material itself. And also it is suggested that the traces should not be placed near the antenna. Any other places, any other traces which carries a different kind of signal, because that may hamper the performance of antenna also. So after taking care of all these parts, we have this kind of placement for the schematic that we previously made. And then I will start with the routing part. And here we have the route error option. These are the settings that we have made. All these settings are in inches. So let's start over here. And as you can see, the layer that you selected is top layer. Sorry, bottom layer we've selected. And we are starting with the routing now. So we'll click on one end of the component, and then other end which is connected will also be highlighted. For SMD component is preferred that the wire should first come straight off the pad, and then it goes to any kind of angle. So as you can see, I am going beneath the switch for the routing part, and all those packages where the pad are at a significant distance, we are allowed to route traces between those pads. But for example, in this case of LED, it is not advised to move the trace between these two pads. That is a required thing. So let's now move to the other part. So the routing is complete as of now, but now we have to make some changes or do some checking on the board. So in the case of the layout, the tool that we'll be using for checking the board is DRC. So we'll click on DRC, and once DRC is clicked, the first option is a file where it says that we can load any pre-made setting for design rules. For example, if we are sending this PCB for fabrication by some outside company, then we may be using their setting to check our PCB, because every company have their own tolerances, their own set of values that they prefer while fabricating any PCB. So we can use the load option to load that setting, or we can save our setting so that we can share it later with other people. Then there is the option of layers. So layers option basically tells us that what are the settings of the copper, that the copper thickness on the top side is 0.035 mm. For single side PCB we can ignore this, and on the bottom side copper is of 0.035 mm, and the core, the insulator between the two layers, is of 1.5 mm thickness. Then we have the clearance option. Normally it says 6 mil, but for in-house fabrication, it is better to maintain even more clearance. So clearance basically means that two non-same signals that may be routed in form of wire. So wire to wire distance will be 12 mil at least, that we have set. If it is less than this, then the fabrication might lead to some issues, because if the traces are very close, then they might even get shorted while fabricating. So it is better to set it at 12 mil. Similarly, the pad to wire distance, as you can see, this is a pad, this is SMD pad, to a wire distance is 12 mil. Then the wire to wire distance is also 12 mil, and similar are the rest of the settings. You can keep the same signal setting as they were at default time. For the distance part, you can see the copper to dimension. So dimension is the edge of the PCB, and it is like written here 40 mil should be the minimum distance that should be maintained between any of the copper trace, copper part and the edge. So this is suited so that while fabricating, if the copper is very close to the dimension layer, then there might be some issue with the fabrication. The copper might get chipped off because it is very near to the edge, so we have to maintain some gapping. Then there is a distance between drill to hole distance that we mentioned, and it is 6 mil. So this is okay for now. Now we'll go to sizes. So in case of sizes, minimum width of copper should be 12 mil at least. Although we have said that default trace width will be 16 mil, but some pre-made parts in Eagle library have a lower width also. So just to support that, we are using 12 mil. Then minimum drill we have set at 0.7 mm. Although we are using 1 mm for the via, but if we set it here at 1 mm, then there might be some issue and Eagle might provide some warnings or errors because some of the components that we use have even lower drill size. Then there is annular ring, and in the annular ring setting, we have this is a very critical setting. So annular ring basically tells that the pad size should be between these two values, the minimum and the maximum value. The pad thickness should be at least this, and this is very highly recommended to do the settings in the case of in-house fabrication, because while we are fabricating in-house, the packages that are pre-made in Eagle have settings for outside fabrication. So we have to make that the pads are of a minimum thickness at least, so that fabrication is not hampered due to lower pad size. So here we have the pad settings where the minimum percentage and maximum settings are given. So here it says that pad on the top side should at least have a thickness of 16 mil, and if it is less than 16 mil, then whatever was the value, we will add 40% to that, and then the value should lie between 16 to 20 mil. So that is the way the calculation is done. And in the pads and wires option, in all the top, inner, bottom, and wires inner options, will set the value to 16, 40, and 20. So you can look how we have done here. So please take a screenshot of this image also. It will be highly recommended while you are doing the in-house fabrication. But rest of the things you can keep same, and then I'll click on apply, and then I will click on check. Now you can see there are no error mentioned, which means that there are no errors. So let's suppose we'll check for some common errors that might occur. So if you have not done the complete routing, let's suppose I have deleted this trace or I have unrouted this trace, and then I go to DRC, I click on check. Now I can see Eagle is mentioning the error as air wire, because air wire means that the routing is not complete, and after fabrication there might be some issue with the board working, hence it has mentioned air wire error. So if I route this trace, then this error will be removed. Other common error that might occur is let's suppose by mistake you are, since you are new to Eagle, there are high chances that you might place one component over other, and now you can see if I go to the DRC option, if I check it, it is saying that there is a clearance error. So you can see clearance error basically, as we had done in the DRC part, clearance was between wire to wire, wire to pad, pad to pad. So here you can see the minimum distance that we were asking to make was not made because of the wrong placement of the components, and now we see the clearance issue. Now then there is a overlap error, and overlap error signifies that two non-same signals are shorted, and overlap error should never be ignored, and even this clearance error should never be ignored. They should be uh, properly handled and removed. So in this case, if I move the component back, now all those errors are removed. So clearance error was basically when two non-same signal wires overlap, and clearance error happen when the clearance setting, that DRC setting that we have made, are overlooked. So all the errors are removed now, and this was with respect to the DRC setting that we should make, and one should always take care of this. So now this is the view that we are getting, and in the manufacturing option, as you can see, this is the PCB view that we are getting. So now let's say if I want to make a jumper or use a jumper on this board. So jumper basically helps us to move from bottom layer to the top layer and then back to the bottom layer. So let me just give you an example of how a jumper would actually look like. So let me just show you. So consider this image that we have, and in this image there is a wire placed. So wire is basically a plated through hole wire, which is plated using a conductive material like tin, and here on the top and bottom side there is copper available. So when I have a signal which I want to carry from this point to this point, and it is not possible to go directly on the top or on the bottom side, then I can do one thing. I will carry my signal from bottom to top, then I will route it, and again using another wire I will get it back to the bottom layer, or vice versa we can do for the top layer also. So this is the way a jumper works or a wire works, that it lets us to move from the bottom to the top layer and then again from the top layer to the bottom layer. So let's just show you how to route a jumper. So let's suppose I want to route this trace not from this side but from this side. One more important thing is that why would we require a jumper? So in complex boards where it is not possible to route the components. So let's suppose this is a board that I have, and it has uh, the traces in both bottom and top layers. So in both bottom and top layer, you can see I have to trace this copper trace, and it is in bottom layer, but I have to trace this copper trace also. So now I'm using the top side to route my traces. So that was a double side board that I have just shown. But in this normal single side board, how to route a jumper is I will showing you. So I have deleted the old trace, and then now if I want to route the error, I will just click here. I will click left click here, and now I am free to move. But I will be changing the layers from the layer option. So I'll change the layer. I will put the wire, then I will put the other end of the jumper, which is in the red color or in the top side. Again I will switch the layers. Once I switch the layers, I will start the routing part, and I will click here. So this way the jumper is planted. We'll start by routing in the bottom layer. We'll place a wire using the layer change, and then we'll route in the another layer. But this routing should either be horizontal or vertical. Angled via are not supported or not recommended in the single layer PCBs. So once I've done this, I will again go back to the bottom layer and I will complete the routing. So this was with respect to the top or the bottom layer wires that we are making, or jumpers, how to use them. Then there is an option to also uh, do add some text in the PCB. So I can just add the PC text in the PCB using the text tool. Let's suppose I want to add an SUT. So for single side PCB, the text should only be added in the bottom layer. So this is how we place the text in the single side PCB. We place it in the bottom layer. So now we go to manufacturing option. Now you can see NSUT is written here. And now I'll also show you. For example, when you see into manufacturing, on the top side you can see some of the uh, things that are written in white color are very close or very on the edge. So we'd like to move them away so that they are properly visible. So we can do that by using the move tool. We click on move tool, we click on the part, and then we can rotate it using the right key. So once that is done, we are able to move the components or the name of the component, as you can see. So we have moved them, and now let's see further what all we can do. So once we have moved it, we can see in the manufacturing option that how the PCB looks. And if you are getting this PCB fabricated from outside, you can simply use the text tool, and the layer that you should use for the top side is T place, and for the bottom side, if you want to, let's say, add some text, you can use the B place layer to add the text. So let me just show you how it will look now. In the manufacturing option, as you can see, it is displayed in the white color. Similarly, this will be visible. This is for the outside fabricators, that we can use this type of layers for the PCB routing, PCB fabrication. And now we will go to the last part of this video, where we will be covering the CAM processor part. And let's just save the PCB. So CAM processor basically generates the Gerber files, and for outside fabrication, these Gerber files are required by the PCB fabricators. So these Gerber file contains data of each layer. So let's suppose in the layer option you can see we have a top layer option given. So this is the top layer. Then we have a bottom layer option given. So this is the bottom layer. Similarly, all the layers or a group of all the layers are actually exported in the Gerber files, and that Gerber data is provided to the PCB fabricator. Also, it is recommended to use smaller size jumpers while fabricating PCBs in-house. So to do that, I can do this thing. I'll just try to move the wire now. As you can see, I moved the wire. And after each such editing, you can also check the DRC, that whether there is some issue or not. So once this is done, let's go to the CAM processor option, and in the CAM processor option there are a variety of layers mentioned, as I've shown. So in the top copper layer, all the pads, so pads appear both in bottom and top layer, they are visible. And then this is the trace that we had in the top layer, that is also visible. In the bottom side, you can see all these layers are visible. In the profile is the boundary of the PCB, so that is visible. Then there is solder mask. So solder mask basically is the area where the traces will be visible. And basically, as you have seen, there are normal PCBs are green in color. As you can see, I'll be showing you. So this is how a normal PCB looks, and solder mask will be that area which is actually exposed, and it will be able to hold solder onto it, and other area will be covered in some kind of resin which might be green in color, and that resin will prevent soldering. So similar goes for the bottom side. Then there is solder paste top and solder paste bottom. So solder paste top and bottom is basically for SMD parts. So SMD part will have the you will be soldered using a solder paste, and that solder paste application is done using these two layers. Like these two areas will be, or these two data files will be required by the fabricator to make the stencil for the PCB. Then there is silkscreen top and silkscreen bottom. So this displays the text or any graphic that we have made on the PCB side. Rest is the drill data, that what will be the where all the drill will be done. And let's just click on process job. So here we had here we have selected the board, the folder for that, and once we open the folder, we can see that there are three folders. These two folder contains the Gerber data. One is Gerber file, which contains all the layer, and the drill data is provided in another folder. So we'll copy this drill data, we'll paste it in the Gerber file folder itself. And once we select this, now I'll be taking you to a website which will help us in displaying the Gerber output, that how our Gerber view will be interpreted by the fabricator. So you can check this website that we have. It is pcbway.com /project /online Gerber viewer. So once you have this open, you can just click on the files and paste it here, or you can just place the pick and drop the files here. Now you can see this is how your PCB will be fabricated. This is the top side, and then there is the bottom side that we have. So this was with respect to the PCB that we have made. We have done variety of changes. We have checked the PCB for any kind of error, and this is the final output of our PCB. So I hope you will look into this video, and if there is any issue, you can point it out.